Hello everybody, Daniel here from Basement Tech. So first I just wanted to say I am really pretty excited. My application for being an exhibitor at the Milwaukee Maker Faire near the end of September this year got accepted. So I'm going to be there talking and showing these same kinds of projects. Look forward to maybe seeing some of you there in person. Do note this is 2017 if you're watching this video at some point in the future, like 2021. I may not be at the Maker Faire in 2021. Anyway, to the project at hand. I wanted to do, and I will do, an intro video for each of the projects that I take on here in the makerspace. I noticed that a lot of people in their videos talk about very specific esoteric details, but fail to step back maybe to the top level and say, hey, what's my system design? How am I thinking about this thing? What are my goals, etc. So that's what I want to do in this video, and I'll do in all of my intro videos coming up. So first of all, this project, I was calling it the surveillance project, but realized that sounded a little bit too big brother. So I think it's more, and it has actually morphed into more of a monitoring project. As I've mentioned in some of my other videos, my son is a knife maker. He recently moved his shop out of my basement into a 1,600 square foot shop, and it's remote now from our house. So it would be nice if we could keep an eye on what's going on down there, not just from like a theft or intrusion point of view, but environmentally as well. So the goals of this project: monitor the zimknives shop. That's kind of the most basic fundamental thing. I do want to learn and practice Python, so I've taken that on as a part of the scope of this project. I'm an electrical engineer, so if I don't have a little bit of fun doing a little bit of circuit design or investigation, then maybe I'm not quite as happy. And finally, I realize as I'm working through some of these things, I'm establishing some design patterns for myself that I can use for monitoring the environmental things going forward in other projects. Note what's not on the list is mass produce this thing. So you'll see in some of my design choices, they're not chosen for, you know, the cost-benefit ratio or any such thing. It's just maybe what I have on hand, or if I want to explore a particular piece of hardware. So the space that the shop is in is, as I said, remote. It's 20 miles away. Also, it's unheated in the winter typically, because it's costly to keep 1,600 square feet at a comfortable temperature all the time, so he turns it off at night and sometimes on the weekends. The knife making involves propane driven forge, so there are combustible gases to be concerned about. So I start to think about those things and what I might like to monitor, and you start to see me, you're probably tired of me panning around the table by now, but you see the components that are starting to come into focus for this project. A camera. I'll talk later about sources of hardware, but I picked this one up for $2, and I'll talk more about the camera because there's a few things you can do to make a webcam like this more useful for this particular kind of application. A motion sensor, again, I'll talk about where that came from, but knowing if somebody enters the space is kind of useful. Temperature and humidity for both the winter and the summer. A flammable gas detector. Panic button. Perhaps in other switches or controls. And then from the output side, what would I do? Well, I might like to turn on a light, and for the astute among you, you've seen probably that solid state relay hiding up there. Maybe make some sounds. There's an amplifier here. Email and text, so I'm talking about an internet connection here. And so later on when I talk about the choice of processor, it might become obvious. The other thing to think about is, hey, how fast moving is this thing I'm trying to monitor? So I'm monitoring the temperature and humidity of a 1,600 square foot space. Not going to change that fast, so I'm not worried about microseconds here. I'm worried more about getting a good measurement in a reliable way. And the motion, you know, if somebody enters the space, I probably want to know that maybe on 1 second intervals, so that, you know, as you see in the movie, somebody doesn't scurry for 5 seconds and stop, scurry for 5 seconds and stop, and then I would miss them. But that's a little bit of a sci-fi consideration, but it was kind of fun to think about. All right, so when I consider the sensors and the hardware that I want to use, there are a few considerations in general. I'll come back to it again, but a lot of it has to do with what's in my junk boxes, which I get from various sources. But I look around at what sensors are available. So for instance, I'll talk about this gas sensor here. And a lot of free advertisement for Adafruit. But if you haven't gone there yet and haven't had the thrill of this box arriving on your doorstep, I highly recommend it. They just save a lot of time, and they have tons of educational videos that they're providing at no charge. So anyway, this is a gas sensor that they provide, and others provide as well. It's not a safety sort of sensor. It's not designed, to cause evacuation of a building based on some very highly precise measurement or any such thing. But and they say that on their website. But it senses many combustible gases, like propane, natural gas, even senses hydrogen. So that's kind of fun. So I thought, hey, that's a cool thing. Let me try that. And later on, when I talk about the topology of the electronics, you'll note that this one has just an analog output. So I need to get that in somehow. They also provide a nifty little temperature and humidity sensor. That makes sense. I want to make noise, so maybe I need an audio amplifier of some sort. Moving to this motion detector, I picked this up for $2 at a swap fest, a ham radio swap fest called a ham fest. $2. This one, as it turns out, is very sophisticated. It does, in addition to thermal, it actually has a microwave backup system where if it detects a thermal anomaly, it attempts to confirm that with a little burst of microwaves. I'll open that up in a future video. It's really, really, really pretty cool. So camera and some environmental sensors. Up here, I have to think about what buttons I'm going to use, and I found some pretty cool ones. This giant one, which glows some color, I think maybe blue, and here's a little red one that I might use, and then maybe some switches for armed or not armed or something like that. So, all right, much of the hardware that I've identified uses either just logic, TTL 5-volt kind of logic, like something like picking up the input from a switch, or driving this device which says 3 volts to 32 volts DC as an input to control 10 amps at 240 volts. That's a pretty significant little device. Like I said, I2C is a favorite of mine. It's really easy. When I put those things together with the need to email, the need to plug in a USB camera and just have it work through some application, the choice of processor becomes really straightforward. And of course, that's the Pi here. I love this little case that you can print. I'll talk in the future about the 3D printer I have sitting next to me. But this is just a brilliant little pretty case that even has a place to screw it down. So it's kind of neat and it's fun. And it's a design that somebody on Thingiverse did. I didn't do the design, but I really like it. I probably printed 10 of those and given them away to friends and used them. So all of this leads to, I need an operating system. I like Linux, and I did say I wanted to experiment with Python. Tons of Python stuff available for Pi, and so that's the natural choice here. All throughout this, and you probably noticed over here, there's lots of little pieces of paper with both things like, well, I bought this thing for $2 and cool, it came with the manual. It turns out this manual has a lot of technical details in it, and that helped me think about how I might interface this device, which it turns out is just a relay closure, into my system. Some things that are a little more detailed, like I said, I mentioned that combustible gas sensor. It's analog, and so maybe I need a good analog reference to read. And then also I need an A to D converter because I've chosen Pi, which does not have analog inputs. But again, my good friends at Adafruit came to my rescue. This is a 12-bit 4-channel for, I can't remember the costs, $10 or approximately something like that. And it's I2C, all in a little board that I can use directly, so I'm not soldering up my own chips. And so, fulfilling my desire to make some sketches and do some calculations that I'll talk about in a future video as well. So sketches, iteration, thinking about it, risk reductions like can I interface that thing if I choose pi? Those are the kind of considerations I make during this phase of a project. And finally, how am I going to power it and or how am I going to package it? So I like to use these little proto boards, but getting the wires off of something like a Pi or an Arduino can sometimes end up in something that's a little ugly and maybe not reliable and maybe not sustainable. But this little wire is available, custom designed to plug onto there. And if I choose a compatible connector on my little proto board, I can have kind of a neat way to get all of those signals off of that board and to my sensors. I do have to think about how to lay all of this stuff out onto something, and I'm literally thinking of the old-fashioned breadboard, which is a piece of wood that's non-conductive from an electrical point of view. As I said, risk reduction. Can I interface that thing and will it work? And so you just start to sketch and think, and then also thinking about how's my software going to be structured? Does that make sense to me? Can I get the kind of timings I need, etc. And so I sketch some of those things out, always writing them down, and that works really well for me. So going forward, I'll do an actual system diagram on some kind of a sketching tool so you can get an idea of how I imagine all these pieces fitting together. The other thing that I think is really important is being able to make incremental progress. So you could imagine any one of these devices would provide kind of an interesting and fun capability in and among itself. So can I just see video from the site? That's pretty useful. Can I just measure temperature through the I2C interface? That's neat. Then I'm working toward this combustible gas thing, and etc. So both take excitement in your incremental incremental progress, and use it as a way to celebrate your successes. So finally, just one note on where this stuff comes from. Some of you might have seen this thing up in the corner. Now this is a junk box, and it literally is stuff I've accumulated over the years, and it hangs out, and I think, well, maybe that will be useful someday. So this is like you see in a building, a skyscraper, one of those huge, loud annunciator things, and I thought that thing must take a crazy amount of current. And I look at the side and it says, no, it's 100 milliamps at 12 volts. Well, that's kind of perfect. It might be fun to scare the crap out of somebody if they're intruding in our space or to announce combustible gases. So I have that as a choice, and I picked that again up at a Hamfest. Hamfest are good. If you go to a place called ARRL, Amateur Radio Relay League.org, and look for the Hamfest, you can see where these electronic swap fests are in your area. They're a great place to pick up stuff like this whole corner, the camera, solid state relay for $5, that thing for $1, I'm sure, and things like that. Usually used, and you have to be pretty picky about the condition and only buy things that you're convinced work, because there's no guarantees, but it's useful. In addition to Hamfest, once in a while you just can't find what you need at a bargain price or used, and you need to buy things. I mentioned Adafruit a lot, and as I said, that's just a way to, kind of really jumpstart a project and save a lot of time in places where you don't think you have things to learn by doing the integration yourself. And finally, just for individual parts, resistors, diodes, connectors, that sort of thing, I oftentimes use Jameco, jameco.com, I suppose. The big deal there is they'll sell really low volumes at a very competitive price, and I often go to them for, as I said, things like resistors and diodes and individual passive components. All right, to finally summarize, let's see if we can just sketch out where we are. We said at the center of this project is going to be Raspberry Pi. This is a Pi 3, has the Wi-Fi built on and in its nice little 3D printed case. How will the components come together? Well, this is meant to be just a really quick and dirty system diagram, if you will. Pi at the middle here. We talked about this gas sensor, the combustible gas sensor. It has an analog input, so I need an analog to digital converter, and I bought one from Adafruit that has analog 4 channels in one side and is an I2C device. Luckily, the temperature and humidity sensor is already I2C, and that's kind of a bus structure, and I did confirm that their addressing schemes are compatible with each other. Coming in, continuing the input side, I talked about maybe a panic switch coming in on GPIO, and that motion sensor is a relay closure, so that'll also come in on a GPIO pin. Finally, closing up the inputs, that camera that I showed will come in on a USB port and be just a webcam. On the output side, we said we wanted to make some noise, so maybe a GPIO driving a transistor which drives that big red noise maker, or some lights being driven through that solid state relay, 120 volt, nice bright lights, maybe even turn most of the shop lights on. And finally, some other indicators, maybe being done via neopixels or individual LEDs, also on the GPIO. And then finally, coming out the audio output, the audio jack, that little 3.5 millimeter audio jack out of the Pi, I have that analog amplifier driving a couple of speakers. So this is just the initial idea. I did realize that I didn't talk in depth about power management, 12 volts and 5 volts and that sort of thing. I'll do that in a follow-up video. So there we have it, the surveillance/environmental monitoring system. And I'll be making individual videos as I integrate each of these components and begin to write the Python code to drive them. So thanks for watching. I know it got a little long here, but always fun to step back and look at how the system design comes together. If you like the video, and if you really like, subscribe to the channel. Thanks for watching. Really appreciate it.